Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refat Bari, aka 800 over 800 guy, is teaching calculus this year. Watch his videos to achieve your dream.
Alright folks, so what's up? We're on the second lecture of the calculus series. I'm going to be doing another set theory problem, so let's get started. So our second problem is the following. We have to prove the following statement. A union B and C is equal to A union B and A union C. Now, how can we prove that this statement is correct? Well, we start by, there's many ways to prove that two statements are equal to each other in set theory, but one way of doing it is by showing that all the elements of the left-hand set is equal to all the elements in the right-hand set. You're probably thinking, what am I saying, right? Well, let's say you have a set of three elements, 1, 2, 3. A set that would be equal to this would be 1, 2, 3. Why? Because all the elements of the left-hand set are contained in all the elements of the right-hand set. On the other hand, if you add a 4 to this, these two sets would no longer be equal. So let's apply the same thinking to this problem. Okay, so our goal right here is to show that all the elements in this set are in this set, and vice versa. Remember, if we just stop halfway by showing that all the elements in the left-hand set are in the right-hand set, that will not prove that these two statements are equal. So let's go ahead and solve the problem. Our first goal is to show that A union B and C is a subset. By the way, this symbol means subset. A union B and A union C. And remember, we also have to show vice versa, the opposite, that A union B and A union C is a subset of A union B and C. Why do we have to show it both ways? Well, let me give you an analogy that's similar to real numbers. If I say that x is greater than or equal to y, and I say that y is greater than or equal to x, then if you think about it, x is equal to y, right? Same thing here. If the left-hand set is a subset of the right-hand set, and vice versa, they must be the same set, and thus these two statements must be equal. So that's the logical reasoning we're really applying here. So let's try to do that. So what do we have here? How do we prove the first statement? Well, the first statement is A union B and C is a subset of A union B and A union C. So to prove this is correct, I'm going to try to say that there's an element x in the left-hand set, right? And I'm going to try to show that this element x is also in the right-hand set. But how do I do that? Well, let me break it up into cases, right? If x is an element of this left-hand set, and the union means or, then x is either an element of A or it's an element of B and C. On one hand, if x is an element of A, then we know x has to be an element of the right-hand side. Why? Well, because the right-hand side includes A. So we conclude that if x equals A, then x is also included in A union B and A union C. How about this one? If x is an element of B and C, well, think about it. If x is an element of B and C, x is an element of B and C, right? That's what I just said. So if x is an element of B and C, then we know that x has to be an element of this one, because you can see B and C is included in this set. So we can conclude that x is an element of A union B and A union C. Alright, great. we just proved that the left-hand side is a subset of the right-hand side. Let's prove the opposite. So, okay. So now I have to prove this statement is true, that A union B and A union C is a subset of the left-hand side. So how do I go about doing that? Well, I'm going to apply the same method, right? I'm going to say that X is an element of the right-hand side. So X is an element of A union B and A union C. Now, you see here that I wrote and, right? Well, that means X is an element of both A union B and X is an element of A union C. Now, we have to prove that both of these will be an element of the left-hand side. Well, if X is an element of A or B, then we know that X is an element of A or B. Same thing here, right? X is an element of A or X is an element of C. Now, if X is an element of A, you see we have 4 cases here. If X is an element of A, it has to be an element of this one because you see A is included here. So that means X must be an element of A union B and C. On the other hand, if X is an element of B, again, you're going to have X included in this because you can see B is right here. So once again, X will be an element of A union B and C. Let's do this one. If X is an element of A, again, same argument. X will be included in our left-hand side. X will be included in A union B and C. How about if X is an element of C? Again, you see that C is included here. So X must also be included in that set. And thus X is an element of A union B and C. And wow, we have just proved that the second statement is also true. Because this is a subset of the left-hand side, and this is also a subset of the left-hand side, we can conclude that all elements X in this set has to be a subset of the left-hand side. Alright, great. By proving that these two statements are subsets of each other, we've proven that they're equal to each other. So thank you for watching, and we'll see you next time.
Subscribe to Bari Science Lab to fall in love with math and science.